Assalamualaikum warahmatullahi wabarakatuh. My name is Mubarak Muhammad Bakri and I'm from Group 5. Today, me and my friend will talk about Experiment 2, Stability of Floating Body. First of all, abstract. The study of metacentric location and the stability of floating body is very important in many applications such as designing of ships. The aim of this experiment is to determine the length of metacenter using the tilting method. The experiment was carried out for various heights of vertical weight and different displacement of horizontal weight, and the angle of tilt was recorded. In the end of the experiment, we predict to have an experimental value to be near to the theoretical value due to specific procedures we have worked on. Next is objective. The objective of this experiment is to determine the height of metacenter using the tilting method and to understand how the buoyant force acts on a floating body. We also want to understand the effect of the position of the center of gravity on floating bodies. Next is introduction. The stability of a body. The stability of a body that floats on the surface of liquid, such as ship, is an obvious importance in our daily life. The height of gravity determines whether the equilibrium is stable, neutral, or unstable. In this experiment, the stability of pontoon may be assessed with its center of gravity at various heights. A comparison with calculated stability may also be made. Next is theory. The weight of floating body acts vertically downwards through its center of gravity G, and this is balanced by an equal and opposite buoyancy force acting upward through the center of buoyancy B, which lies at the center of gravity of the liquid displaced by the pontoon. To investigate the stability of the system, consider a small angular displacement delta theta from the equilibrium position. As the body rotates, the buoyancy force will act on the centroid of the new volume displaced, which then form a restoring couple with the weight, which causes the body to return to its original equilibrium condition. However, if the body is tall and slender enough, a small rotational displacement can cause the floating body to be unstable, as the buoyancy force and the weight form an overturning couple. In this experiment, the stability of pontoon is determined with the CG at different height. If a horizontal weight is moved with a distant x from the center, the pontoon will tilt. The angle of tilt can be measured using the plumb bob. The equilibrium condition of floating body can be determined experimentally using this following formula. Next is methodology. The horizontal weight is removed and the height of the vertical weight is fixed on the mast of the pontoon. Step 2. By putting the pontoon mast on the pontoon stabilizer, the center of gravity is determined. The length of CG, which is half the distance from the base of pontoon to the center of vertical weight, is measured. Step 3. The horizontal weight is fixed and the thread is ensured to be 0 mm position. Step 4. The tank is filled with water and the pontoon is placed in the tank. Step 5. The length of the pontoon, which is submerged in the water, is measured. Step 6. The horizontal weight is moved 10 mm to the right and the angle of the tilt of the thread is recorded. Step 7. Step 6 is repeated by moving the horizontal weight to the right with the 10 mm increment. The angle of the tilt is recorded. This step is repeated until the plumb bob, which is hanging on the thread, touches the side of the pontoon. Step 8. we repeat the step 7. We repeat the step 6 and 7 by moving the horizontal weight, this time to the left. And step 9, the height of the vertical weight is adjusted to the new height, and step 1 to 3 followed by step 5 to 8 is repeated. This test is done with different value of vertical height.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad from Mota, and I'm going to present the part for the results. For the results, we were given the x and the theta for the movement to the right and also to the left for each test. Test 1, test 2, and test 3. And we use the result to calculate the GM, which is the equation of Ws over W tan theta. We use the value of x and theta to use in that equation to get our metacentric height. For the discussion, we are asked to plot the graph GM versus theta for each test and determine the value of GM from the plotted graph when theta is 0. And as you can see in the graph, we plot the graph for each theta and the value of GM, and then from that we can draw a line of best fit, and from the line of best fit we can find the value of GM when theta is 0. And we can also see that in the equation in the graph for test 1, for movement to the right, we can get that the GM, the value of GM when theta is 0, it is 0.0266. And it is also the same principle for the other tests, for test 1 movement to the left and test 2, test 3 respectively. Moving on, for test 1, we can get that the CG is actually Y, and it is equals to 0.132 meters, and the D is 0.019 meters, where the value can be found in the table. And we use that value to find the GM for test 1. And we can get that when we put the value in the equation, we can get that the value of GM for test 1 is 0.708 meters. And we do the same thing for test 2 and test 3, and which is 0.74. And then we also do the same equation for movement to the left as well, for because this is movement to the right. While for the comparison between theoretical and experimental result, we can see that in the table, the comparison is between theoretical result and experimental result for the movement to the right. And as you can see in the table for test 1, our experimental result is 0.0266 meters, while the theoretical result is 0.708 meters. And for test 2, our experimental result is 0.065 and the theoretical result is 0.75. And for test 3, our experimental result is 0.0911 and the theoretical result is 0.765. And we can calculate the percentage value from the equation where the experimental result minus theoretical result over theoretical result times 100. While for table 2, it is a comparison between theoretical result and experimental result for the movement to the left. Okay, and as you can see in the test 1, our experimental result and theoretical result is 0.038 and 0.708 respectively, while for test 2 it is 0.0543 and 0.74 respectively, and for test 3 it is 0.0722 and 0.765 respectively. While for the percentage error, we can see that the percentage error for test 1, test 2, and test 3 is 52.26%, 50.23% and 45.96% respectively. For the discussion part 3, we are asked to discuss the reliance of the meta-center on the position of the center of the gravity in terms of stability of floating body. The stability of floating bodies, it can be measured by meta-center height, GM, which is the distance between the center of gravity and the meta-center. The meta-center is the point of intersection lines of action of buoyant force through the body before and after rotation. As the value of GM increases, the stability of the body also increases. Bottom-heavy body is usually stable because the CG is below the CB, which is the center of buoyancy. Okay, and it can be either way. If CG is above CB, the center of displaced volume shifts to a new position during a rotational disturbance, and this will lead to two possibilities. One is if M is above CG, it will create a positive GM, and two, if M is below CG, it will create a negative GM. And when GM is positive, a restoring moment will be created during any rotational disturbance, which causes the body to return to its original position, thus causing high stability. While for if GM is less than 0, if it is negative, an overturning moment will be created instead and giving the body an unstable equilibrium. And therefore, it can be shown that the meta-center relies a lot on the position of the center of gravity in terms of stability in the body. For the discussion part 4, we are asked to discuss the effects of variation in angles of tilt on the position of the meta-center. And as you can see from equation 3, where Gm equals to Ws over W tan theta, it can be seen that Gm is inversely proportional to tan theta. Therefore, we can conclude that when the tilt angle increases, the value of Gm decreases, and it can also be proven in the table, in the experimental table that we made. For the conclusion, we can conclude that the values of height of the meta-center are different for the calculated value and the graph values, and the location of the meta-center varies for different height, and it's not fixed on only one point, and it also changes when the pontoon mass is tilted and form an angle. Also, the meta-center is conversely related to the angle form.